Derek a second to set up and give you a little intro for him. I think for those of you that have been in some of these conferences, you've seen Derek a lot. He is a VP at Sonatype and talks a lot about DevSecOps, especially the software supply chain. I think everyone here uses different libraries, whether it's open source or anything else, and talking about how to automate and all the facets of the security process there. So, give us one more second. Put in his credit card PIN number. No. Was that an A or a B?
Wow. Okay, so you don't need that. Hopefully that's, hold on just a second. Let me turn off wireless, because otherwise that's going to come up and bug us. So first of all, I want to thank the DevOpsDays Dallas organizers for putting on this event, because I've been to a lot of DevOps days. And a DevOps day in general is like as big as that quarter of the room, and that quarter of the room, and that quarter of the room, and that quarter of the room. This is a huge DevOps days. Secondly, this is a huge day two. Usually if you're speaking on day two, you have half the audience of day one. So thank you, everyone who listened to me yesterday and said, hey, Derek said show up on day two. There must be something good. So as he said, I'm Derek Weeks, Vice President at Sonatype. I'm also... Plug it in. Isn't that like the first rule of IT support? Okay. So I'm Derek Weeks, Vice President at Sonatype. I am also one of the co-founders of All Day DevOps, which I'm excited about coming up on November 6th. But I'm excited to share with you some research today that I've been doing for the past 5 years, and over the last 10.5 months, I've been doing with Gene Kim and Dr. Stephen Magill and a host of other security and security researchers and data scientists. An organization's journey to excellence begins once it ceases to sacrifice quality for speed. And you're thinking, we're at a DevOps conference, dude. Speed is awesome. We're all here for speed. We read the Dora report. Gene and Jez and Nicole told us last year in the State of DevOps report that leading organizations in DevOps practices are deploying 64 times more frequently than their peers. Their mean time to recover from outages is 2,600 times faster than others. Their change failure rates are 7 times lower. They're 1.7 times more likely to extensively use open source across their environments. And that particular point on the extensive use of open source is where my work over the last 5 years intersected with Gene Kim. And we started talking about how open source was used across development. Every single one of your organizations uses open source in a massive amount. And for those of you that have read the Phoenix Project, if not, order it on Amazon right now. I won't mind if you're not listening. But in the Phoenix Project, the first way of DevOps is understand the performance of the end-to-end system and never pass a known defect downstream. That's the first way of DevOps. Now, the end-to-end system in open source looks like this. Every single one of you has a software supply chain. There are suppliers, warehouses, manufacturers, and finished goods. You rely upon open source projects, and in this case, for our research, we studied over 36,000 open source projects. We looked at over 30 million open source component releases over the last 10 years. We also looked into 12,000 software development organizations and their practices and surveyed over 6,000 software developers this year. We also analyzed 68,000 applications that were built using open source components for this survey, or for this study. This is the end-to-end system that every one of you is relying upon. You're relying upon it so much. Let me give you an idea of just the scale of this usage. In Java development, there are 10 million Java developers around the world. They requested 146 billion downloads last year, up from 87 billion the previous year. If you're developing in JavaScript, you're one of the 6.5 million JavaScript developers, you all download 11 billion NPM packages a week now. You are extensively relying on open source. And because of this, the applications that you're developing have a footprint of open source that's about 85 to 90% of the application of code that you did not write yourselves. Why? Because you want to go fast, right? Speed matters, right? And why spend a month writing some code from scratch when you could download it from the internet in a second? We want to go fast. In the average organization, just doing Java development, you're consuming 300,000 Java open source components every year. To do this, you're relying on over 2,700 open source projects or external software suppliers for that code that you didn't want to write yourself. And there's kind of no secret out there that not all of these parts that you're relying upon are created equal. Of these parts that your organizations downloaded, 27,000 Java components came into your organization with known security vulnerabilities. Not all parts are created equal. So while the State of DevOps report tells us that faster is better in the enterprise, what we wanted to figure out was were the same concepts that apply at the enterprise scale also applying to the suppliers that we have within the open source community that we're relying upon. And we wanted to understand if there were better suppliers and worse suppliers, what are the attributes of these great suppliers out there that we want to use and the others that we want to avoid? So comparing the enterprise to open source projects, like, these are two totally different worlds. In the enterprise, you have multiple deploys a day, multiple deploys a month, multiple deploys a week. In open source, you have version semantic releases. You have consistent development teams in the enterprise. You have pretty fluid development teams in open source. If I have time, I may contribute. No one's paying me. I'm busy, I'm on vacation, I'm doing whatever, I'm bored of that project, let me move on. In the enterprise, you're well-resourced. Most of the time, you're well-resourced. In open source, it's a little more variable in terms of the resources available to you. But we can see similar metrics between these two types of organizations. One is, you like to look at deployment frequency. We can look at release frequency or update frequency of open source projects. You like to look at organizational performance. How much revenue do we have? How much market share do we have? How many customers do we have? In open source, you can look at the popularity of these projects. In the enterprise, if something goes wrong, how fast can we get back to normal? In open source, we want to know how fast can we update things, or if there are security vulnerabilities or other things, how fast can we remediate those? So we embarked upon this study, and I'll go through a couple of different hypotheses that we went through. But first, I'll tell you a little bit about the data set. So in order to do this, at Sonatype, we happen to sit in a nice place to get data like this because we run the Maven Central Repository. So we were able to look at a lot of data from 260,000 open source projects in the Java community. And we needed to look at these and figure out which ones could we rely upon, which ones had multiple releases that we could look at, times to update, and so forth. Which ones followed a standard versioning system that we could rely upon? Which ones have been around for a while to see the number of downloads they have? And we ended up with 36,000 open source projects that we could evaluate as part of this study. And we looked at their popularity, the size of development teams, the development speed, the release speed, were they using CI platforms, update speed, security, vulnerability updates, et cetera. So we looked at a lot of different attributes to try and figure out, were there any patterns within these attributes that we could identify the best suppliers with? So the first hypothesis that we entered into this research with was that projects that release frequently have better outcomes. Just like enterprises that release frequently have better outcomes, as the State of DevOps report says. So this hypothesis was validated through our research, that projects that do release frequently do have better outcomes. They're 5 times more popular. They have 79% more developers than their other peers within the open source community. And they have 12% greater foundational support within these projects. So that was fairly easy to find in terms of the data set. The harder thing to find in the data that we spent months and months collecting and getting at was time to update and time to remediate things like vulnerabilities. Now this is important because every DevOps talk has to refer back to W. Edwards Deming. I think that's like the rule of John Willis. He started it. Damon Edwards mentioned him yesterday. But W. Edwards Deming in the late 40s and 50s was advising Japanese manufacturers on high-velocity manufacturing processes. And some of the key principles that he brought to the table there were, we need to identify and detect and fix known defects in the supply chain before they're passed downstream. He also had this principle of, you need to pick the fewest and best suppliers in the market and pick the very best parts from them. This is decades ago in manufacturing, and we can apply these same kinds of attributes to selection that we can make in the software suppliers that we rely upon. So as part of this, we wanted to study 3 different metrics: the time to remediate vulnerabilities, the time to update dependencies within these projects to see how quickly they were doing it or how frequently they were doing it, and were there any stale dependencies? Were there any components, versions, or dependencies left behind where projects didn't always update to the latest version? So to give you a sense of how this works, there's a simple model of a timeline. You read the model from left to right up here. This model represents a core component, C. We start with version 2.2. It has 2 dependencies, A 2.2 and B 2.2. And we want to see what happens between the release of C 2.2 and the release of C 2.3. And this is what we were studying. So what you can see in this model is between the time C 2.2 is released and C 2.3 is released, the component B has a vulnerability discovered in it. That open source project has to update their code to remove the vulnerability. And during that time, that's when B is vulnerable. But during that same time that B is vulnerable, because B is a dependency of C, C is also vulnerable. So we needed to measure the vulnerability time of C. And if C were going to remediate that vulnerability, it had to update B. So from the time B 2.3 releases to when C 2.3 releases, that's the remediation time, and also its update time for B. But C also has to rely on the update time for A. So we have to wait for A 2.4 has been released. When is C going to adopt A 2.4? And you'll notice that A 2.3 was skipped. C did not update to A 2.3 within its release cycle. So it wasn't necessarily always updating. So we did this kind of study for 36,000 open source projects, no matter how many dependencies they had, and this took a while, but thankfully we have machines to do a lot of the analysis. And what we found was that the quality in terms of remediating vulnerabilities was perhaps not as good as you would want to imagine with your suppliers. So the median time to remediate vulnerabilities across this population was 180 days. Half a year if a vulnerability was appearing, how fast could your project update it before you could actually take that and put it into production? The mean time to remediate was almost a year, and for the 95th percentile, they were at 3.5 years. Now, at least they updated their dependencies to remove those vulnerabilities, but they were still vulnerable. That was a supplier that had a security vulnerability for 3.5 years. But not all's bad. There were some projects in the top 20% of projects that were doing really well here. So we wanted to figure out, like, here are projects that are updating really fast, and what attributes do those projects have? But we couldn't look at, not every single open source project has a vulnerability. So the data set on that was pretty small. And this is why we then went to, well, how fast are projects updating in general? When new dependencies are available, or just new features were available, how fast were these projects updating? And the cool thing that we saw within this research was that there was a strong correlation between the median time to update and the median time to remediate. So those projects that had very strong and very consistent median times to update their dependencies in their code were also remediating security vulnerabilities faster within those projects. So hypothesis number 2 that we had within this study was that projects that update their dependencies frequently are generally more secure. If you're going to use any projects, we validated this hypothesis that you want to use projects that update frequently. You don't necessarily need to pick which of the projects are the most secure. If you see projects updating more frequently, pick those or rely upon those as your suppliers of the code into your enterprise and organizations. The next thing that we wanted to look at, or the next hypothesis that we led with, was that projects with fewer dependencies would stay more up to date. This makes sense. That model that I showed you with A, B, and C, right, and A and B being dependencies, if you have 2 dependencies on your single project, it's pretty easy to update 2 versus I have 17 dependencies and I need to update every one of those with every version that ever gets released, and things get complicated, but that's not true. What we actually found was that components with more dependencies actually had better median times to update than their peers. Now, why is this? We don't necessarily know why, but we know what. So larger development teams have a 50% faster median time to update within this study. And this is a smooth chart to kind of show you on the y-axis how large is the development team, and on the x-axis how many dependencies did they have. Now this is kind of takes a little bit to absorb, so let me make it easy for you. If you're a 2-pizza team, right? You have more developers, 4 to 6 developers, 4 to 6 developers. That's enough for 2 pizzas, I think. And you have more dependencies. So we don't know if more developers bring more dependencies and that's why there are more dependencies, but what we do know is larger development teams also have more dependencies, and they're faster at updating those dependencies in general than their peers. So now, this is probably the most interesting hypothesis that we led with, because it changes the way we need to think about software and the software we rely upon. More popular projects should be better at staying up to date. And why is that true? Who's read The Cathedral and the Bazaar? That's like, it's an awesome book. It came out in '99. That was a while ago, but it's still an awesome book. And in that book, Eric S. Raymond introduced Linuss's Law. And you've all heard this before. With more eyeballs, all bugs are shallow. In the time of Linux development, in the early phases of Linux development, when open source was evil and don't use that because proprietary is better, well, with more eyeballs, all bugs will be shallow in this open source community. We have so many people looking at this project that any bugs will be uncovered quickly. That worked when there weren't that many open source projects, right? Right now, there are millions of open source projects. There are over 30 million individual releases of those projects. So when we looked into the data, we actually found there are plenty of components that are really popular, but not all of those components have strong median times to update. And therefore, not all of them are the most secure components that you could choose from. So their time to remediate is not that great, and their time to update is also not that great, and their deploy frequencies are not necessarily that great. So in this study, the other thing that we were able to find, and I'll show you a little more on that in just a second, but we were able to find 5 behavioral clusters in this. And these are the clusters that determine what are good suppliers and what are not so good suppliers when you're relying upon this code. So there are 2 exemplar groups that you'll see on the left. One is the small and the other is the large. The small exemplars have almost 2 developers on average. The large exemplars had almost 9 developers on average. And they were releasing very frequently and updating more frequently. The large exemplars were more likely to be foundation supported, or as Stephen Magill liked to call it earlier when we were talking about this, the open source industrial complex of foundation supported suppliers. The laggards in this, or the poorer suppliers, had poor times to update. They had high rates of stale dependencies, so when their dependencies updated, they didn't necessarily update to those latest versions. They were more likely to be commercially supported. We also found projects that introduced new features really fast, but didn't necessarily update their dependencies at the same time they were introducing new features. And then there were also the cautious that they had pretty good times to update, but they weren't trying to stay on the bleeding edge of the latest versions of dependencies. So they'd get there, but they were a little slower than the others, right? So this is where we're beginning to look at, could we qualify the attributes of suppliers that, again, you have 2,700 open source suppliers just in your Java development teams on average, right? How do we pick the best ones and what attributes do we rely upon? And this is really what we were trying to find out in this study. So this is an eyeful, but this is a really cool chart when you get a chance to dive into it. And I'm going to try and simplify it a little for you. So on the x-axis, we have release frequency. And if you're on the left side of this picture, you are releasing fast. You are updating fast. If you're on the right side, you're updating slow. You're the laggards within this community. The higher you are on the y-axis, the more popular your components or projects are by download counts. And what you'll see here in this pink rectangle, the large exemplars and the small exemplars are all cluttered in this left side. They release fast and they're more popular. I think I have time to mention this for a second. So Gene Kim pointed out that curve right there at the bottom. There are no unpopular projects, low popularity, that release frequently. It's kind of funny when you think about it. Like, no one's out there going, I just want to release code really fast and often. No one's using it, but I just have to release code really fast, right? So these are the suppliers that you want to use. Now, with many eyeballs, all bugs are shallow. The most popular projects don't necessarily have the best track record. So when you're relying on popularity as your only attribute, you are not being well served. Popularity cannot be the only attribute that you choose your projects upon. Now, as we were going through this research, Gene and Steven kept asking me, like, okay, like, we're seeing these behaviors in the open source projects, but what are developers doing? And I said, why don't we go out and survey a bunch of developers? So in May of this year, we went out and surveyed 600 developers, and we asked them about their practices. Are you updating your dependencies? Do you have a process in place for this? Are you applying any automation to updating your components and dependencies and versions you're using? Do you have a process to remove troublesome components from your environments? And now the data came back surprisingly high in all these regards in terms of, I expected like 10% of people were actually doing this. So seeing 30s and 40s and 50% of development organizations applying these practices was fairly surprising to me. And maybe it's just survey data, so people are a little more aspirational in their responses, but the behavior was clearly there. The behavior was also clearly there to help us identify exemplars within these environments. So the exemplars in this survey were 10 times more likely to schedule updates. They were 11 times more likely to have a process in place to update their components and dependencies. They were 12 times more likely to have automation assisting them in these environments. But so that's cool. There's a process, there's automation in place. But the kicker, like the really important thing here, is those that are doing this, the exemplars, on a regular basis, are 2.6 times less likely to consider updating components painful when there's a vulnerability, 3.2 times less likely to consider this activity painful when just updating dependencies on a regular basis. So if you're climbing this mountain every day on a regular basis, on a regular cadence, you're deploying frequently, updating frequently, it's pretty easy. And you know what? Your developers are happier. If you haven't updated your dependencies or open source components in an application this year, or you haven't done it in 2 years, or maybe more, you know how difficult it's going to be to climb that mountain? It's really hard to climb a mountain once a year, but if you're climbing the mountain every day, it becomes easier. So you see the exemplars, not only are they easier, but their developers are happier. So now we also wanted to understand, when it comes to what you're putting in your applications, what are we seeing in terms of the open source component usage in those? We looked at 68,000 applications. And we looked at the age of components within these applications. And the good news is at least 50% of these components are newer components. They've been released in the last 2.5, 3 years. 50% of the components you're using on average are pretty old components, which should be updated to more current versions. And there's a reason why. Because when you look at the newer components released more recently, those have 65% fewer known vulnerabilities in them than the older ones. If you just used components that had a release in the last year, pick any version of that release in the last year or 2 years, you can drop your vulnerability defect rate in half. Just in that practice alone, the age of the components that are there. So in 2010, Jez Humble and Dave Farley wrote Continuous Delivery. It was an awesome book. And they talked about building quality in. The first chapter, it's not like buried deep on page 243. The first chapter talks about continuous delivery and building, not only building fast, but building quality in. So how do we support this in a DevOps practice? Well, you're thinking, hey, couldn't we automate this? Brian, back in the back of the room, was like at dinner the other night. He's like, we could automate this. Like, yes, you could automate this. So in a survey we did in January, 5,500 developers, we asked them 2 back-to-back questions as part of the survey. Do you have an open source policy? And if you do you follow it? In the non-DevOps practices, 25% said, yes, we have a policy, and yes, we follow that. In the DevOps practices, or the exemplar group, 65% had a policy and followed it because these organizations applied more automation to their problems in order, or to their practices, I should say, in order to surface information about better quality components, or just open source policies that are automated saying, use these good components, don't use these bad ones. So they're 2.5 times more likely to follow the policies your organization set when they're aided by automation. And the vulnerability rates drop in these environments as well, that the managed software supply chains have 55% fewer known vulnerabilities in the applications. When I looked across all of these applications that came from non-managed software supply chains, the finished applications, remember the software supply chain? The finished goods were on the right. 20% of the open source components in those applications had a known vulnerability. Almost 21%. 1 in 5. There's like an average of like 106 open source components in those applications. So like 20 open source components in your standard applications, if you're not looking, has a security vulnerability in it. So if you take information from this study, and this is really what we are getting at, right? Enterprises can move fast, but do the suppliers that we rely upon also have these same attributes? And can we identify those? And if we do, can we characterize those for our choices? And because of those choices, develop our applications with very high quality while still maintaining the speed that we want to maintain within the enterprise. You could also look at this as like when Brian and I were sitting at dinner, he's like, we could automate this. If we knew these attributes, we could automate these into the system, right? And so imagine an automated rating system for your OSS components. Imagine as a developer, if you know a 2-star supplier versus a 5-star supplier. And when you pick that component, you're like, yeah, I want to rely on the better, not just the most popular, because I've been using it for 6 years, or my friends are all using it, or that's just what we use at this enterprise, right? But we have a rating system in place that could do this. This doesn't exist yet, but the data that we're bringing out of this study helps this come along in our evolution. Imagine building secure applications where quality is built in from the start. That we're not building applications with 20% of the parts in it that are known defective when at the time that we put them into these applications. And this was a cool thing. I was meeting with a Gartner analyst a couple of months ago. And he was like, I'm talking to people, in my organization outside, and like, I see software development 10, 20, 30 years down the road. And we're not going to have developers, anymore. We're going to have machines that are so smart, they're able to build the applications themselves. Because right now, you're not writing 85% of your applications. Those are coming from parts from external suppliers. And if you're getting to like 95% of your applications are open source, and then machines are able to identify which are the best parts from the best suppliers out in the industry, machines could effectively begin to code by themselves. Now, no one's out of a job, right? You're all safe. It's totally good. We're all safe, for at least for the next decade. Your kids, no promises. But software development is changing. This kind of information, this kind of research was so exciting to do with Gene and Stephen to reveal this. We're just beginning to see the attributes of like how this is important, how we're going to apply this into software development. So, if any of you want a copy of the slides or a copy of the 2019 State of the Software Supply Chain Report, I'm going to make it really easy. Take out your phones, take a picture, write it down. My email address is weeks@sonatype.com. My out-of-office message is on today. That will respond back to you with links to the slides, to the report, to the DevSecOps community survey that I mentioned. And you don't have to put in a subject line or anything or say thank you. Just email that address and it will respond back with the links. You don't need to register to download anything. They're on SlideShare. You can download the documents from there. For those of you that do, there is one small gift in that email that I will offer your organizations. So for any of you that want to bring back something really valuable, not just these slides, which you'll have to try and explain to them after you read the report, but I put in a gift in that email for all of you. And I want to thank everyone in Dallas for attending today. I want to thank the organizers for putting on an awesome show. I've had a great time here. I'm going to be here through the rest of the afternoon, and I think we're about to head to break. Thank you.